Hello, I'm Mark Littlefield, Director of System Products at Elma Electronic. Welcome to Part 3 of our Introduction to OpenVPX. In this episode, we'll discuss backplane apertures and connector modules, how they're defined, and their importance to the OpenVPX standard. Since its first publication in 2010, OpenVPX has seen the introduction of many new and significant features, including radio clocks, VITA 46.11 chassis managers, higher speed backplane connectivity jumping from 3.125 GHz up to our current 25 GHz speeds, and fully defined slot profiles supporting modern, high-performance communications protocols. However, arguably the most significant advance is the introduction of backplane apertures and connector modules, culminating in the VITA 67.3 standard, which defines new configurations for coaxial and optical blind mate backplane connectivity. Apertures are openings in VPX backplane slots that enable the use of blind mate coaxial and optical connector modules. Likewise, plug-in modules have gaps in their backplane connectors to accommodate coaxial and optical connectors matching the backplane. The connector modules requiring apertures are defined in the various VITA 66 and 67 standards, and the type of aperture is defined within the individual VITA 65.0 slot profile. The importance of these backplane connector modules is that they can be defined according to a system's mission and installed and replaced by the end user. The different backplane apertures defined by the standards and their slot profiles can support connector modules with different arrangements of coaxial and optical connectors for each aperture size. VITA defines these blind mate coaxial and optical connectors in a series of standard documents. These documents and their linkage to OpenVPX is a bit complicated, so it's worth taking a little time to outline them. The basic concepts and rule language are captured in the VITA 66.0 and 67.0 optical and coaxial blind mate connector-based standards. Specific implementations of blind mate connector modules are captured in subsequent .specifications. These include for VITA 66, VITA 66.1 MT variant, defining a full aperture connector module with dual MT connectors, VITA 66.2 ARINC 881 Termini variant, VITA 66.3 Mini Expanded Beam variant, VITA 66.4 Half-Width MT variant, VITA 66.5 Hybrid variants, which also add support for 1-inch pitch boards and increased connector densities. For VITA 67 we have VITA 67.1, half-sized 4-position SMPM configuration, VITA 67.2, full-sized 8-position SMPM configuration, and VITA 67.3, spring-loaded contact on backplane, which adds a host of new features and connector styles. However, OpenVPX does not fully support all of these. The standard does not call out support for VITA 66.2, 66.3, or 67.2. In addition, VITA 66.1 is supported by only one slot profile in OpenVPX, and VITA 66.4 and 67.1 support is limited, with no new content added since 2017. OpenVPX does, however, extensively support VITA 66.5 and 67.3. In addition, 66.5 and 67.3 actually reference each other, so they can, in a sense, be considered a joint standard. As I mentioned previously, the purpose of these apertures is to support blind mate coaxial or fiber ribbons that pass signals through the backplane. This allows rigid or semi-rigid flexible coaxial or fiber cables to be installed behind the backplane rather than draped across the front of plug-in modules, as was done in the past. This improves system reliability and allows for more precise control of these connections. The 6U module example shows VITA 67.3 connector modules in the J3 and J6 locations. In this example of a VITA 67.3 implementation, we see that the plug-in card is using edge-launched SMPM contacts off of 3 mezzanine levels. This design approach saves significant space and weight on the plug-in card, as well as eliminating noise sources due to multiple connectors. This is an example of 2 different types of contacts that can be used on VITA 67.3 apertures. In the upper right-hand corner, you can see 4 cable assemblies that would be snapped into the top row. Below that, you see edge launch contacts that might be used to launch directly from a mezzanine and/or a base card. This shows the flexibility designers have when designing for VITA 67.3 connector modules. The illustration on the right is from the VITA 67.3 standard, and it shows a 3U slot profile with a VITA 67.3c module located in place of the J2 connector. The table defines the location of each possible aperture within a 3U or 6U slot. An X dimension is given for each possible backplane location and is in relation to the center of the upper alignment key. The VITA 67.3 document also shows the locations for half-sized modules. Similar location charts can be found for the necessary aperture locations in VITA 67.1, 67.2, 66.1, 66.4, and 66.5. The various VITA 66 and 67 dot specs define the required mounting holes for each size aperture. In this example from VITA 67.3, the reference point and cutout dimensions are given for each aperture size. The location, type of contact, and the coordinates for the contact locations within the module envelope must be defined by the original connector module designer and are recorded in a VITA 65.1 table. Here is an example from VITA 65.1 of how the contact type and its position coordinates are shown for each defined VITA 67.3 connector module. VITA 67.3 also defines the numbering scheme for any number of contacts. This chart from VITA 65.1 defines the XY coordinates and type of contact within a given VITA 67.3 connector module. There is a separate chart for each VITA 67.3 module. This colorful table shows how to decode an OpenVPX slot profile name. You can see it contains all the many options for the slot profile and is described in detail in VITA 65.0, section 1.3.3.1. The resulting string describes the various features of the slot profile, including the arrangement and size of the various communication pipes. Notice that the slot profile name in this example ends with 14.6.11. This is the VITA 65.0 section where all the details of this particular slot profile are defined. This particular slot profile contains one Type H aperture cutout. If you look at the chart, it will show that the H indicates that it supports a VITA 67.3c module. If it had been a J, it would support the 67.3d half-size module. Because the slot profile name can now become so very lengthy, engineers often simply refer to the relevant VITA 65.0 section, such as 14.6.11, because it's easier to type and speak than the entire slot profile name. Lastly, note the -n at the end of the string. This is used to indicate the specific connector module, if any, that is populated in the backplane slot or that a plug-in module supports. This value is found in the relevant slot profile table of VITA 65.1. In the case of the connector module shown in the previous slide, it is designated with a -4. Here we see 4 sets of slot profiles. Each slot profile illustration is shown next to a photo of an actual backplane slot. Working from left to right, the first pair of images shows an OpenVPX 14.8.7 slot profile, which contains a half-sized VITA 67.3d aperture. Notice that the photo shows that the aperture is filled with a VITA 66.4 half-size MT optical module. The second and third pair of images are both for slot profiles containing full-sized VITA 67.3c apertures. In these two examples, the aperture replaces the J2 connector in a 3U slot profile. The first one is an OpenVPX 14.6.11 slot profile, which the photo shows the aperture to be populated with a combo connector containing 4 SMPM coaxial contacts as well as an MT optical ferrule. The third example is a 14.9.1 radial clock profile, which also contains a 67.3c aperture. However, the photo shows that in this case the aperture is populated with a connector module containing 10 SMPM coaxial contacts arranged in 3 rows. The last pair of images is an OpenVPX 14.8.8 slot profile, which contains a VITA 67.3e aperture, which is also referred to as a full plus half because of the connector space it occupies. The photo shows the aperture populated with a module containing 12 SMPM coaxial contacts. It is important to remember that each slot profile aperture can support many different connector modules fitting that aperture size. Each connector module defines a different arrangement of contacts. The 3U 12-slot SOSA-aligned CMOS backplane is shown here. Note that 8 of the 12 slots contain VITA 67.3 apertures, specifically slots 3, 4, 5, 8, 9, 10, 11, and 12. Note that they're all VITA 67.3C apertures. Thank you for joining me today in this tutorial on OpenVPX slot apertures. I hope that you found this useful. For more information, please visit the ELMA website at www.elma.com. I'm Mark Littlefield.